Simplifying radicals. A couple of things for us to know. We have a radical, which is the yellow bar. We have a radicand, which is the value of the number inside the radical. When you simplify radicals, you're going to start with prime factorizations. Now, I will show you some shortcuts, but all in all, really what we're thinking about is what are the prime factors for whatever value the radicand is. We will then remove the pairs. Now, we say pairs simply because we're dealing with a radical that doesn't have a value showing, so we know the value is a 2. So that's why we're looking for pairs. Once we've removed the pairs, we multiply the remaining singles both inside and outside the radical symbol. Multiply the remaining pairs both inside and outside the radical symbol. Now these are your steps. A couple of shortcuts. While we are looking for prime factors, we've also been memorizing perfect squares. So anytime we can reduce a radicand to be a multiple of a perfect square and any other value, it's going to allow us to take the square root of that perfect square much quicker and simpler. So for example, if I have something like the square root of 192. Where's my pen? And we divide that by, let's go ahead and pull out the 3 factor. Gives me 3 and 64. Now, we all know that we can simplify 64 down further than just 64. But since 64 is a perfect square, I prefer to box it, because that's going to remind me that it's a square, and take its square root. Square root of 64, 8. Now let's look at some more examples. So I do the square root of 84. We want to first look for what factors we can find for 84. So 84 has the factors. Let's start with 2. 2 goes into 8 4 times. 2 goes into 4 2 times. All right, we can factor that further. 2 again. 2 goes into 4 2 times. 2 goes into 2 1 time. All right, we can no longer divide by 2, but we can divide by 3 times 7 gives me 21. So we could, if we wish, rewrite the square root of 84 as the square root of 2 times 2 times 3 times 7. And hopefully you realize that 2 times 2 is 4 times 3 is 12 times 7 is 84. Now your directions told you to find your pairs. So in the radicand, I see that I have a pair of 2's. We can pull out a pair of 2's because remember, 2 times 2 is the same thing as 4, and the square root of 4 is simply 2 all by itself. So this pair of 2's simplifies out of the radicand and comes and gets placed in front of the radical. Anything that cannot get pulled out of the radicand simply gets put or multiplied back together. 3 times 7 is 21, and we have completed the problem. All right, pause the video, see if you can model that same process for the square root of 60. All right, welcome back. So we want to look for our factors of 60. So 2 goes into 60 30 times. 2 goes into 30 15 times. 2 no longer goes into 15, but 3 goes into 15 5 times. So we have the square root of 2 times 2 times 3 times 5. Pair of 2's simplify out. 3 times 5 becomes 15. Now, yes, they are going to get slightly more complicated to this because these are just basic introductory problems. Oh, now we have a number already sitting in front of the radical. Well, don't worry about that number yet. We know the radical functions like a variable. We also know that the radical functions like parentheses. Now remember last week I told you this radical could also be written as a fraction 28 to the 1/2 power. So notice my radical, instead of looking like a radical, now has parentheses with an exponential power. So I could say -2 times root 28. Whoops, put that in the wrong spot. Where we now want to know what our factors of 28 are. 2 goes into 28 14 times. 2 goes into 14 7 times. So let's see. We have -2 outside still because we're just continuing to bring it down times the square root of 2 times 2 times 7. Where I see I have a pair, they can come sit in front. And we can now multiply, let's see, -2 times, we just brought the 2 in front of the radical. Root 7 is the only thing left in the radical. Now, somewhere you saw your directions said multiply everything outside, multiply everything inside. There's nothing left inside, but we do have a -2 times 2, which gives us -4 root 7. Go ahead and pause the video and try 2b. All right, welcome back. 72. Our factors, 2 goes into 72, 3 with a remainder of 1, 12 would be 4. All right, 2 goes into 34, 1 time, remainder of 1, 14, so 17. 17 is a prime number. It's not going to simplify any further. So we have 3 getting multiplied by the square root of 2 times 17, where I have a pair that can come sit in front of the radicand. 3 times 2 root 17. And now we can multiply our 3 times 2, which gives us 6 root 17. So as you can see, the more practice you get with simplifying radicals, the faster this whole process is going to go. And eventually, the less work you're going to have to show to do it. At this point in time, these are the steps I want to see. I want to see your prime factorization. I want to see what's in the radicand, what came out of the radicand, and then your final step, show me your simplified solution, what got multiplied together to become what. All right. Well, now we end up with an interesting situation. We've got variables and their powers. Now, there are a couple of different ways of approaching this. One way is to remember back to what we said this radical represents. X to the 5th times y to the 16th. The radical itself is a representation of a 1/2 power. Now, the nice thing about a 1/2 power is we could certainly say x to the 5/2, y to the 16 times 1/2 is 8. The only catch with that is I am not going to allow you to have a 5/2 power, which means you've either got to convert 5/2 as a fraction notation back to a root notation, or we need another way of processing this problem for right now. The alternative way of processing this problem comes from your understanding of deconstructing exponents. You want to deconstruct your exponent to end up with an even exponential power. So that would look something like, well, the next lowest even number is x to the 4th. What do I need to multiply by x to the 4th to get x to the 5th? I need to multiply x to the 1st. Now, at this point, this problem becomes much easier because our pairs since it would be similar to multiplying 1/2 times 4 now, are essentially half of the exponential power. So let's circle or square anything that's got an exponential power that's even. Those are the items that will square out perfectly. So x to the 4th power, half of those become x squared outside the radicand. Y to the 16th power becomes y to the 8th outside the radicand. And now we just write what's left inside the radicand, x to the 1st power. Now, if you really need to, you can take this process and write it in expanded form. The square root of x times x times x times x times x, that's 5 x's, times y times y times y times y, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's an awful lot of y's. And now we would circle our pairs. I have a pair there, which means I can pull out an x times x. All right, I've got a pair, 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 and a pair. So I can pull out 1, 2, 3, 4, 5, 6, 7, 8 y's, and the only thing I have left inside the radicand now is an x all by itself. And then, just like our direction state, we multiply back together. What's outside, we multiply what's inside. X is by itself inside, so I don't need to multiply anything together there. On the outside, however, we have x times x, which is x squared. We have y times 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 y, which is y to the 8th power, root x. Notice we got the exact same answer, but you filled half your page writing it in expanded form. To just realize that our x to the 4th is going to pull out half of its x's. All right, take this knowledge, go ahead and pause the video, and apply it on question 3b. Welcome back. So the first thing I want to do is try to make as many of my powers even. So x to the 12th, y to the 1st, I can't make that even. Z to the 4th, which means I need one more z. So I'm going to be able to simplify the x squared. I'm going to be able to simplify the z to the 4th, which means I'm going to be left with yz inside the radicand. X to the squared means there are two x's, half of them come out, so just x. Z to the 4th means that there are 4 z's, half of them come out, and that's going to leave me with 2 z's outside. So xz squared root yz. All right, now let's combine. We have both numbers and bases that are variables. Same process. We want root. Let's find our factors of 12. So they would be 3 and 4, 2 and 2. So let's start with the numbers. 2 times 2 times 3. Again, I want to make my variable have an even power. So x to the 6th times x. And we want to identify our pairs. I have 2 2's, so a 2 will come out. I have 6 x's, so half of them will come out. And put together what's left in the radical. 3 times x is 3x. All right, you try it with question 4b. Welcome back. All right, 72 is a number. X squared is already an even power, so we just need to find our root 72. So our factors, 2 goes in 36 times. 36, notice, is a perfect square. Since 36 is a perfect square, I'm not going to factor it any further. I'm just going to box it. Boxing it reminds me that it is a perfect square. So we can say square root of 2 times 36, which we box, times x to the 10th value. All right. 36, since it's a perfect square, is a combination of 6 times 6, so we would pull out 1 6, or we just know that the square root of 36 is 6 because we memorized it. We can pull out 6. Either way, we're pulling out a 6. X to the 10th, we want to pull out half of our x's. So we've used that. What's left? Root 2. And we're done with simplifying that problem. All right, now you're going to see that they get a little bit more complicated because we have some combination on the inside that's going to take place, some combination on the outside that'll take place. We're going to start with simplifying the inside. So I want to start with looking at my value, but we've got a 100. That's nice. 100 will actually get boxed, but let's come down and simplify. Root 100, which is going to get boxed, times x to the 6 times x, that gives me 7 x's, times y to the 6. Now, all of this drops down in front. So we haven't had to do anything with it yet. 6y to the 11th. Now we start pulling out. The square root of 100 is 10. X to the 6 means I pull out half of them, so x to the 3rd. X to the 1st, we can't do anything. There's just one x there, I can't take half of it out. Y to the 6, we can take out half of them. And then we see what's left in the radicand, x. Now remember, in our previous step, we just dropped this down because we didn't do anything with it. Now we're going to drop it down again. 6y to the 11th times 10x cubed y to the 6th. We remember back to our exponent laws that tell us we can't have coefficients that are not multiplied together, and we cannot have any variables with like bases, any powers with like bases. So we need to simplify these further. Now you are welcome to, if you need to, rearrange the order to these because this is 6 times y, 10 times x times y. So I could certainly say 6 times 10 times x cubed times y to the 11th times y to the 6th. If it makes more sense for my coefficients to be next to each other and my variables to be next to each other as their like bases. At this point, we just use our normal multiplying rules. 6 times 6 is 10 is 60. X to the 3rd, well, there's only one x, so it's already simplified. Y to the 11th times y to the 6th. If we have two terms with like bases, we add their powers. 11 plus 6 is 17, so y to the 17th power. Root x. Now, root x does not count as a like term to x as a base, although technically one could say that x to the 3rd power times x to the 1/2 power would result in like bases. But at this point in time, we're going to leave them in the radical because our goal for today is simplifying radicals. So this would be your final answer. Go ahead and pause the video and see if you can give 5B a try. All right. Let's see what you got. I already noticed that I have x squared. It's already an even power. And we want to find our roots for 40. Now, I'm going to go a little bit different on this problem because, again, notice that 40 has a 4 in it And 4 is a perfect square, so I've already pulled out a factor that is a perfect square and is going to be quick and easy to take the root of. Roots of 10 would be 2 and 5. So we have negative 5x to the 5th power times the root of 4 times 2 times 5 times x squared. So I'm just going to simplify the radical. Root 4 is 2. X squared, we take out half of them. X. Put everything else back together. So 2 times 5 is 10. And drop down what was in front of the radicand in front of it again. So negative 5x to the 5th. And so we're going to combine terms. Now this time I'm going to do it without lining all of my pairs or my values up together. So we have a negative 5 times 2 gives me a negative 10. We have an x to the 5th times x to the 1st gives me an x to the 6th root 10. And we're done with that question. Now, I want you to take just a moment to complete the placemat, all 6 questions, and then come back and check your answers. All right, welcome back. So 63 has the factors 9 times 7, where 9 is a perfect square. So we have root 9 times 7, which is 3 root 7. X to the 15th is the same thing as x to the 14th times x. So we can take out half of our x's. That will leave us with x to the 7th times root x. 75 x to the 6th. So I have an even value of the exponent with the base that's a variable. And we want to find our factors of 75. Well, 75 I already know is a factor of 25 and 3, where 25 is a perfect square. So we'll end up with root 25, which is a perfect square, times 3 times x to the 6th power. We can take out half of our x's. We can take out this perfect square. So 5 x to the 3rd root 3. 3 root 500. Well, the only thing in there is a number, so let's find its factors. And it is a multiple of 100, which is a perfect square. So 100 times 5. So we have 3 times root 100 times 5, where 100 is a perfect square. We will simplify the radical first. So the square root of 100 is 10 root 5, and we're going to drop down whatever was in front and multiply it to our radical. So times 3. 3 times 10 is 30 root 5. All right, next question. We have an even number of powers. We have an odd number, y being to the 1st power, but there's nothing I can do with y to the 1st power. We can already see it's going to stay in the radical. And then 12. So let's see, I got room over here. 12, our factors of 12 are 4 and 3, where 4 is a perfect square. So we're down to the lowest values we need. Negative 2 times root of 4, which is a perfect square, times 3 times x to the 14th, which is an even power, times y to the 1st. So let's clean up just the radical first. Square root of 4 is 2. Oops, why did I do that? Is 2 times half of our x values, x to the 7th. Now everything else can go in the radical. 3y to the 1st. And bring down our negative 2. Negative 2 times 2 is negative 4. X to the 7th root 3y. All right, last question. I have an odd number of powers. So we're going to have our odd number of x's. We're going to have to do something with that. And I have a 20. So 20 factors down to 4 and 5, where 4 is a perfect square. Come on. So we have 3x to the 6 root 4 times 5 times x to the 1 less to give me an even number of powers times x. All right, 4 is a perfect square. X to the 4th can be simplified. So let's simplify just the radical first. Square root of 4 is 2. X to the 4th, half of the x's come out, x squared. Everything else stays in the radical, 5x. Drop down our 3x to the 6 and multiply together. 3 times 2 is 6. We have like bases. X to the 6 plus 2 would be x to the 8th root 5x. All right, check your work. See how many of those you got right. Hopefully you did well on them, and you can do some of the practice today. Have a good day.